project for April. Okay. I think the fight goes cute. It's not like it's like you said, tiny enough. It's not like there was a doc. Who knows what we will be? They're kind of. But without the printer would actually is run on. So yeah. That's what people think. There's other things. Yeah, I told them. So I think.
All right, young scholars. Today we're going to work through 5 programming examples. And after today is the last programming homework assignment. The next 2 Thursdays, we will do some programming examples during our Thursday class meeting. However, there'll be no assignment associated with them. So first, we're going to work with a bubble sort. Then we're going to do an example of a selection sort. Then an example of an insertion sort. Then an example of a quick sort. And then I'll also show you how to use arrays.sort to sort integers with an array in ascending order, just like the homework. However, technically, all of these would be able to sort an array in ascending order. So first, I'm going to create a new class called bubble sort. As you saw with most of these sorts, they're all going to require some kind of for loop in order for them to keep running until all of the numbers are gone through. So within our public class bubble sort, we're going to have to create a method. And then within that method, we're going to create an integer array. So int bracket bracket. What do we want to call our integer array?
Numbers.
Numbers, okay. Then we have our different style brackets with the little pins on the end of them. And our semicolon to end the line. So what numbers do we want to add in here?
1,
Okay, 1,
9,
9,
28,
28, okay,
17,
17, okay, How about two more?
5,000.
5,000. Okay. One last one.
Um,
85.
Okay. So now from looking at those numbers, 1, 9, 28, 17, 5,000, and 85, we know that our display should give us 1, 9, 17, 28, 85, and 5,000 as the order. But in order to do that, now you remember how a loop works from Tuesday? Where it just compares the next number on the right. And if it's smaller, it moves to the left. If it's bigger, it stays right.
Yeah.
So as a result, our for loop basically has to replicate that.
Yeah.
So for integer, we'll just call it I. If it equals 0, then we check to see if it's less than our number's length, which is the size of our array, minus 1. How can we do minus 1? Whenever it's an array, our elements and our index. Remember, element number 1 goes in index 0. So the element minus 1 gives us the index. Then lastly, I++, so that it keeps going until all of our numbers are covered. Then we have to do the same thing for our elements. So we'll do int j equals 0, j less than numbers.length minus I minus 1. And then j plus plus.
That is true.
That gives us our element. Index element. So now we need to create if statement within our for loop. So if array numbers j is greater than j plus 1, we continue to run. Then we'll create a new integer called temp. If you recall this, we're passing our numbers, our integers from the array into that new variable int temp.
I think it should be.
As that goes through, we then set our numbers. J equals to numbers J plus 1. This updates the array once a number has been used / sorted. And then lastly, we pass that to the variable temp. So in each instance, we're in essence overwriting something. The array is passed to the temp. Numbers J plus 1 are passed to numbers J. Numbers J plus 1 is passed to temp. Everything continues to be overwritten through that for loop, which in essence does what we showed you on Tuesday, continues to check. Okay, first we have 1 and 9. Is 1 bigger than 9? No, okay, it stays on the left. 9 to 28, okay, 9 is smaller, stays on the left. 28 and 17, okay, 28 is bigger, it moves over to the right-hand side. Now 28, 5,000. Oh, okay, 5,000 bigger, it stays right. 5,085, 85 smaller, it moves to the left. So that is what this entire for loop is basically doing. Continue to check the next number and move it where it needs to be moved based on its position. So lastly, once we get out of that for loop, we now need to print out a message. So what do we want to print out to the user? Oops. It would help if I could spell system.out. What
I
message?
can say, congratulations, here are your numbers in order.
Okay. But what if we wanted to specifically tell them it's a bubble sort? Can we just add congrats? Here are your numbers in order via bubble sort? That works.
Yeah, I think that worked.
Let's put a colon at the end of the statement instead of a period and leave a little space. That just prints out a message. We now need to run another for loop that's going to continue to print out the next number. So we're going to create an int number that's going to pass our array. And we would have to print out within that for loop what would we have to print out? We would print out that new integer num that's taking on all of the numbers. And then we'll put a space in between each number. We compile and run this first example. Our output should say, congratulations, here are your numbers in order via bubble sort. And then 1, 9, 17, 28, 85, and 5,000. All of that stuff I showed you in class on Tuesday that we would think kind of takes us a few minutes to look through. Since these are powerful machines, it all happens behind the scenes and does it for us. So we go and run our program. Congratulations, here are your numbers in order via bubble sort. 1, 9, 17, 28, 85, 5,000. Just as we predicted, they all came out that same way. So the next one we're going to do is a selection sort. And you'll notice there's going to be some similarities and some differences within the required for loops. So when I create this new class called selection sort, we start by doing the same thing as our bubble sort. We have to create a method where we're going to create our integer array. So what do we want to call this integer array? Instead of numbers, maybe num or num.
Maybe list or something?
List. Okay. And then do we want 6 numbers again, 5 numbers, 8 numbers? How many numbers would we like to put in this one?
7's a good number. 7's a solid number. Good luck.
7?
Mhm.
So we'll put 7 to start. And what about the other 6?
83,
Okay.
5,
Okay.
106, 512, and 3.
Okay. So we know again, from simply looking at it with our eyes, the orders should be 3, 5, 7, 83, 106, and 512, right? So ideally, when we compile and run this, that will be the order in which they're displayed. But again, we need to create that for loop so that we know the difference between our elements and our index. Within selection sort, we have to create a mini index. Let's just call it min index. Make it simple on ourselves. And we make sure that it equals that I. So every time the for loop runs, it's going to be overwritten. But instead of like our bubble sort, where we did numbers j plus 1 equals temp, we're going to do that right within a for loop here. The j equals I plus 1. And so long as there's elements still in our array, we continue. So we have to check, is the index have something in it? Is there an element there? And as long as there is, we're now going to pass that array list off to J, so long as it's bigger than this min index we created.
Oh, yeah. Oh, sorry. We're kind of like, we're just kind of.
And our min index is pushed through J. Somewhat similar to what we did within our for loop for the bubble sort. However, we did it in 2 less steps. But then we jump out of that for loop, but still within our method. And we create a temporary integer in order to take our initial I. Then we pass that to our min index. Then lastly,
This is within the first for loop.
this is outside of the for loop.
Outside of the whole thing.
Yep. So see the for
Okay.
loop here? This is outside of all of that. And this continues to overwrite each of our numbers until we're completely finished with our numbers. So how many times is this
Sorry, real
going to
quick.
run?
Real quick. It looks like it's still in the first for loop, just counting the brackets. I might be wrong.
The first for loop,
Yeah, click on the bracket of the beginning bracket of the first for loop, please. It looks like it's that what you wrote there is within it. See?
yes, it's within
How it
the
highlights-
first one, not
Oh,
with the
okay.
second
It's within
one.
the first one. All right. That was my question.
There's a second for loop here. Sorry about that. So it's within that first for loop, below the second for. So as the for loop runs, based on the number of elements you have. The array is updated
Yeah.
to move/sort the elements. So unlike bubble, which just compares left and right and moves them over, selection just goes and selects. Okay. 7's bigger, 7's less than 83, it stays. 5 is less, okay, move it before the 7. Okay, 106 is bigger, it stays. 512 is bigger, okay, it stays. 3, nope, that's the smallest. It goes there. Up, but 3, 7, that's not in order, okay? 7 gets bumped over. The 5 switches with it. So selection sort is probably about half the time as a bubble sort, because selection sort just checks every number. And then, okay, this is smaller, this is bigger, and moves them around. Whereas the bubble sort takes it 2 numbers at a time, switches them in their order, and continues to move forward. So then lastly, we need to do the same thing we did with the bubble sort, where we give some kind of output as well as a for loop to output the numbers. So what message do we want to tell the user? Hey, your numbers are now in order because of the selection sort. How about just a simple, here's the sorted array from our selection sort.
See, I think I remember when we came in. Put a couple of them on, and if that can stay.
But then we need to create a for loop in order to continue to print out our numbers until it went through the entire array list.
No.
So again, I'm going to do a for loop and just simply make the integer number. And we pass that array list into that integer number. So this way our 3 gets printed, our 5 gets printed, our 7 gets printed, etc. And then lastly, we would have to print out that new variable. And let's put some space in between each of them. So as you saw with the bubble sort, that for loop is passing the array elements to the integer num and is printing out all the array elements with space in between them. So the initial for loop we create with the for loop inside it goes through and checks every single piece. Okay, is this element in order? Is this index in order? And then prints them out once it's all sorted, one at a time. Without running this initial for loop, we're not going to have it necessarily in order. If we got rid of that, we would just print out our list in the order we had it: 785, 5, 106, 512, 3, etc. And you'll notice the minor difference here. All of those rewrites, if you will, in the bubble sort all had to be done within the second for loop as an if statement. Whereas in the selection sort, it can be done outside of the if statement, but within that first for loop. So if we go ahead and compile and run this, here's the sorted array from our selection sort. 3, 5, 7, 83, 106, 512. All of them in the order they should be displayed. And then within an insertion sort, which we're just about to do right now, you'll notice again that instead of an if or a for, and an if, now we're going to have a for and a while. All of these different sorts have all of their different nuances to them. So we called this one insertion sort. And just like the other two, our first step is to create a method where we set up our integer array. So what do we want to call the integer array here? We did numbers and list already. Let's just make it simple. It's an array. We'll do ARR. Then we need to put a number of numbers in our array. So what numbers do we want to use?
We can start off with 5.
5 again, okay.
$28,
Okay,
300,
300, okay. How about 17, 19, 2? How about like 3 more?
75.
75, okay. How about Aaron?
86.
46,
I said 86, but 46 is good.
46, 86. We can add as many as we want here. I'll do 99 for Aaron Judge. How about one more? How about we do 2 again? We'll have 2 2s. So first we need to create our for loop just like we did in the previous examples. However, instead of setting them to 0, why are we setting them to 1? I'll give you a hint. What happens after the 1? I less than whatever your array dot length minus 1 is for each of them. That's what we did with the bubble and selection sort. Here, we're just doing our array length. There's no minus 1. Then every time it runs, what did I do? Misspell?
No, I think you need to do I is less than.
Up, yep. Here I was so busy showing you the difference between this one and the other ones, I didn't put the entire statement in. So it's I less than just the array name dot length instead of I less than array length minus one. Because with an insertion sort, we're assuming that there's going to be more and more numbers. Even in the comments, I can't spell the word length. So we're just going to assume there's more and more numbers being added or inserted that need to be checked. So now I'm going to pass the numbers from our array into an integer called key. Then, again, I'm going to create an integer j. That'll be our I minus 1. And again, as you saw previously with the selection and bubble sort, that's done to check our element number and our index number. So still within our for loop, we're going to add a while loop. While j is greater than or equal to 0, and. What does and mean? Nobody remembers?
It means like you're like
It just
and
means and, right?
array. Yeah.
Yep, you're checking both of them. So while j is greater than or equal to 0 and our array with that j inside is greater than key, it continues to go while both of those conditions are met. Then within that while loop, again, we're going to continue to overwrite elements. So the array j plus 1 equals the array j. And then instead of j plus plus, j minus minus. Okay, we checked the previous one. Move on to the next one. Then still within that for loop, but outside the while loop, we now pass the new number to the key. And again, all this basically does is checks the element. How many elements do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it knows there's 11 elements, 11 indexes, but the index starts at 0. So it continues to drop through, switch the numbers out, print them out in the proper order. That's why the more numbers you have, the longer it might take for it to go through that entire process. Then lastly, just as we did with our selection sort and our bubble sort, we have to give some kind of message to the user and then create a for loop where we're passing everything from our array into a variable to easily display it. So within that for loop, we pass everything in the array once it's sorted into that int number integer variable, and then print it out with a little space in between. But what message do we want to give the user beforehand? We told them with the selection sort that, hey, here's the sorted array from our selection sort. With the bubble sort, we said, congratulations, here are your numbers in order via bubble sort. What would our little message to the user be to tell them, hey, you're using an insertion sort to do this? Do we just want to be plain Jane and be like, your insertion sort worked? Does that work? Or do we want something clear, better?
Yeah.
Does it even matter? Not necessarily. We're just telling the user that, hey, an insertion sort was used here. So we go ahead and compile and run. Your insertion sort worked. 2, 2, 5, 17, 19, 28, 46, 75, 86, 99, 300. So as I mentioned on Tuesday, we have two twos. We don't necessarily know which one of these twos went first, whether it's this one or this one. In theory, we're going to assume that that first two that we have listed in our integer array was the first one used. But we don't necessarily know that. It may have started on the back end based on our for loop. Okay, there was 11 numbers. Let's start at 11. And the 11th element, check that first. So when you have multiples like that, it's just going to show you both of them next to each other. You're not necessarily going to know unless you checked the index, but that's beyond just sorting. So we're not going to worry about that today. Then our fourth today is going to be a quick sort. You saw that on Tuesday. That's the one that you have to have certain parts that are broken together. I'm going to call that one quick sort for my class name. So we'll have public class quick sort. And we have to do the same thing as we've done for the others. Creating an integer array. What do we want to call this one?
B.
B, okay. And how many numbers do we want to enter into this one?
Um,
4, 5, 6, 2, 8.
Well, we can do 6 numbers.
Okay. So I'll just make them 92, 19, 45, 7, 88, and let's say 7 again. Now you're going to see that a quick sort is completely different than our insertion sort, selection sort, bubble sort. We have to use a method called quicksort, where we pass our array 0, our array dot length -1. And after that, we're going to print out a message to the user. Let's just make it a simple message. Here's your quick sort. Then we have to do the same thing as we've done with the others. Use a for loop to pass our number through. You'll notice we did it fairly quickly, right? Up at the beginning before doing anything else.
So my program is not recognizing quicksort as a method. It wants me to create a method for it. Is there something I need to import for it?
No, we haven't created the method yet.
Yeah.
Oh, okay, okay.
So this quick sort method we're just about to create right now.
All right. I was just making sure.
So that's why you'll see Amelia's getting the same error probably as I am. We have not created this quick sort method yet. So that's what we're right about to do. We create a new method called quicksort, which is going to match what we have above. We're passing our integer array B. But then we're creating an integer low and an integer high, which is basically how many elements do we have? How do we get through them? So within that method, as long as low is less than high, we create an integer called pivots that's going to partition or break them apart. You'll recall previously, I showed you on Tuesday with the quick sort, it breaks everything apart, then puts it back together. So then, for a quick sort, we pass our array, that variable low, and then that variable pivots -1. Then we have to do the same thing for the high. Pass the quick sort, that array B, the pivots, this time +1, and then high.
I mean,
So in essence, one does the checking for the index, one does the checking of the elements. So you'll notice we're calling this partition method, but we don't have a partition method. So the next thing we need to do is create that partition method. The public static int partition.
do you want to work in Becky's office? Unless you have, yeah, we'll hear it doing.
We're going to match the same as our quick sort method. We're going to pass that integer array B, create an integer low, create an integer high. Then we're going to create an integer called pivot. It's going to pass that high of our array into that integer pivot. Then we'll create an integer I, which is just our low -1, which is in essence our index. Next, we need to create a for loop where integer j is going to be low, and as long as it is high, less than our high, we add 1 to j. So in essence, we're doing the same thing that we've done with our insertion, selection, and bubble sort to check our element and index, but within their own specific methods. So within that for loop, we create an if. So if our array is less than the pivot, we continue to add 1 to our I. Then we create an integer temp. And we continue to overwrite our numbers.
Yeah, but they have other locations.
Until all of our numbers are displayed in the proper order.
But what programming was important, all of them? Yeah. This is, you're going in advance? Yeah, no, I know, but it says 6 others, how many do you need? They say.
So then we jump out of that for loop, but still
You don't make any.
within our partition method.
Oh, just that, yeah. You pick time with every season.
We set our integer temp equal to the array. We continue to check the next one. We check the biggest number.
Yeah.
And then lastly, we return I plus 1. So notice how there's so much more involved with this because we're breaking it apart and then putting it back together. What error did I cause now? What did I misspell? 2 errors.
It doesn't like my J's. I'm getting an error in partition. It said like for int J equals low, J is less than high, J plus plus. And then when I go to if B of J, and it says J is like, it cannot, what did it say to me? Cannot be resolved to a variable. I don't know why that would be.
I'm not sure either. Try another letter instead of J, like Q, R.
Okay.
Oh, no, I got.
Where am I missing a semicolon?
Boom. The time of my life.
I found it. I added a semicolon. That was my problem.
Do I have a semicolon added somewhere?
I don't think so. I just noticed mine where it shouldn't be at the end of the for loop and partition.
Public static void main. Oh, I see. I have a bracket instead of a open parentheses there, and then it run. So right here for my public void main, I had a bracket
Can I look
instead
at
of the parentheses.
partition again real quick?
Yep.
Can I look what you have for partition? Yes, thank you. That's all.
So you noticed here, as I mentioned, we had to create a second and third method, quicksort and partition, to go ahead and do all those extra steps of breaking it apart and putting it back together. So in spite of its name, quicksort, technically it's a little more involved than the other types of sort. Now the difference is, while the code is longer, the process is quicker. So think of it like you're throwing a puzzle on a table and the Tasmanian devil just runs by and then the full puzzle comes out done on the table. That is, in essence, what a quick sort is designed to do. So then I go ahead and run. Here's your quick sort: 7, 7, 19, 45, 88, 92. All of it is done fairly quick. Much quicker than us just looking at it. No, okay. However, behind the scenes, that quick sort is quicker than the bubble sort and the selection sort and the insertion sort.
For work.
So lastly, I'm going to create a class called sort numbers. Now this one, I'm going to show you how to use just the arrays.sort method. So in order to use it, you have to import. It would help if I could spell. You have to import the arrays. So we import java.util.arrays. Then we create, in this instance, I called it sort numbers, our public class. And just as we did with all of the others, we're going to create a method where we create our integer array. So what do we want to call this integer array?
Yeah, just make sure you have room to grow.
Bob, George, chicken, what do we want to call it? Since the other day was Halloween, let's call it candy. And then we would put however many numbers you want within your array. So 17, Amelia said she likes 7.
Yeah.
Grace said 75 before. Let's try 46 again. 82, 999, 1, 5, 96. So then we could use the arrays.sort method to sort them in order. And you'll probably use this example for the homework, and that's fine because it's much simpler than the other ones. All you would do is arrays.sort, and what would be the parameter that we pass here? What would be the parameter for arrays.sort?
Okay.
What's the name of our array?
Candy.
Yep. So arrays.sort, and then your parameter is the name of your array. So in this instance, arrays.sort candy. So then our last piece, we have to print out a message to our user. What do we want to call this message? What do we want to display to the user as the message? How about, we'll just be comical to them. The arrays.sort method is so much easier. And then lastly, we have to do the same thing we've done for all of them by passing that all of our integers from our candy array into an integer called num. And then print it out so long as there are still numbers inside. So that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code compared to all of the others. So you can utilize that arrays.sort that's already in that import for arrays. So if we go ahead and run, arrays.sort method is so much easier and puts all of the numbers in a row. Now, since we have some time, I'm actually going to create a bonus class for us. Sort strings. And I'll copy the code from sort numbers. I'll have to change my class from sort numbers to sort strings. But if I wanted to make an array with strings, what would I have to change?
You'd have to change it from int to string.
Yep.
And also change like what you have inside of the array. So the numbers with strings.
So let's just make it simple and just have 4 strings. So Bob, George, Happy, and Cat. Is this going to run? Or do I still need to change some things? We could keep this variable named num, but since it's
But
now
you
a
have to say that
string,
it's a string.
yep, we have to change it from int to string. So now when we compile and run this, what do you think will be our order for our string array? A, B, C, D, E, F, G. What's our order going to be?
Alphabetical?
Yep. Should be Bob, Cat, George, and Happy, right? Let's hope that's what we get. No. How come it didn't go in order?
Uppercase versus lowercase.
Uppercase versus lowercase. So if we just make it Bob, George, Happy, Cat, that's going to be the difference.
I think so. They have different
Yep.
codes, the numbers.
If you know it, go with it. I'm just asking because I want to see if you're sure or not. Remember, Java's case sensitive. So when you put Bob and George lowercase, it went in alphabetical order. When Bob and George were uppercase, they went first in that order. So Bob, then George, then Cat, then Happy. When they're all the same case, it went in the alphabetical order that you'd expect. So remember to keep that in mind with your strings. So you might even want to have 2 separate arrays. One with, names, one with your other types, cat, happy, because your names you're always going to have capitalized. Your other items you're always going to have lowercase. So I'm going to post all of that up onto Blackboard momentarily. But as mentioned, your last homework assignment, you're going to write a program using any of the sorting options we just did that will sort numerical numbers in an array from smallest to largest. So you notice whether it was sort numbers, quick sort, insertion sort, selection sort, or bubble sort, all of them did that. No matter what the order of the numbers were in your array, that's what all of them did for you. So I'm going to go up and add in all this code for everybody. So the first one was bubble sort. Copy the code from the bubble sort. Okay, which one's next? Selection sort. So any of these different sorts we went through today would accomplish the task for homework. Now, obviously, quick sort has much more code involved than the other options. And just using that arrays.sort obviously has the least amount of code required. Next, we have insertion sort. Now, I just showed you the example for strings, just using arrays.sort, but you could, in essence, do the same thing for all of the others. You would just have to make those minor changes, demonstrating your array type. Quick sort.
What else is right? Yeah, and that was your what is that before war?
And then lastly, our sort numbers and sort strings.
You got it. All right, so the number three. What's the point? I chose. Yes. So why do you think this position exists?
So all of the code should now up for you to look through. And like I said, you're more than welcome to use any one of these for homework 10. But I'm going to assume you'll probably go with the easiest of using arrays.sort. That's perfectly fine with me. But again, this is the last homework assignment. All we have left for the remainder of the course is our take-home exam and the group project. So once you're finished with this, you may want to take the next couple of weeks, start setting up your meetings with your group member and going from there based on your group project. The,
Your bigger numbers?
let me see where the take home is. So the take home is in the folder in 2 weeks, and you'll have until December 4th to do it. So what is that? 16. So about 3 weeks to do those 3 questions for the take home exam. So if there are no questions, I bid everybody adieu, and I will see you next time.
All right.
Professor,
Yes.
what were you saying in the beginning of class?
What was I saying at the beginning of class?
Yeah.
Not 100% sure. That was a while ago.
Did we miss anything at all? We came a little late.
Yeah.
I might have just been going through the list of the programs we were going to go through.
Okay.
Okay. Next week?
No, today. The one we did.
Oh, okay.
Yeah. So, I'm gonna head out then. Bye, Professor.
Okay, take care.
And there's class next week, right?
Yes.
Okay. Thank you. Bye.
Now be sure to find the rest of the 26. You have. I'm sure, I was just gonna say, I think I kind of.